This is the second video in our Introduction to Databases for Accountants case that we're working on. In the last video, we left off with this workflow. We have our 4 data sets. We've browsed them to see what variables they have. And now what we want to do is manipulate each data set, and eventually we want to join them together. So if we look here at the document I gave you, we bring into the Alteryx the 4 data sets with an input data tool, which we've done. We may need to change the data types for the variables in the data sets from the default string, vstring, to the type that makes sense. So if it's a variable that obviously is a numeric variable, you should change it to a double data type. If it's a character variable, you can leave it as the default vstring or change it to just string variable type. And then if it's a date variable, we're going to have to change that to a date variable type. Also, any values in any of the 4 data sets that do not make sense should be deleted, as they are likely errors, and including them will skew the analysis. So I gave an example here. In the orders data set, there's a quantity of 0 for 2 customer orders in the order details data set. And that doesn't make sense. So let's go verify that. If we go, let's start with order details here. Actually, you know what? Let's start with customers and work our way down and then across. Let's do that. So in our customers data set, if we browse this, we just have our customer ID. Now that should be a numeric variable. All these other variables should be a string variable, with the exception of, it looks like, zip code. Although we're not going to use zip code later on, we can convert that to the proper data type. So what we can do here is we can attach a select tool, and also with our browse tool, we're looking for null. We're looking in each column, making sure it says 100% okay. If it says 99% okay and 1% null, so we'll look for null values. We want to potentially get rid of the null values depending on the context, and we'll see that here in a second over here in the orders data set. So in the customers data set, there aren't any null values in the columns. So when we change our data types, let's change customer ID number to a double. And then there are other things, the rest of these can just be strings or variable width strings. I'll just change them to strings although it doesn't matter, you can keep them as variable width strings. Here, I'll just keep it. I shouldn't change it. There's no need to necessarily change it. vstring, variable width string, or string, they're all the same. They're string variable types. So by default, it's a string variable type. We can leave it as that. And then the zip code should be changed to a double. It's obviously a number, a numeric variable. Phone number isn't, you would say that's a number, but it's got the parentheses around the area code, and it also has a dash to separate the area code from the other 3 from the other 4. So that's a character variable. We'll leave that character. All right. So that's customers. For order details, if we browse, we want to change, well, ID number clearly isn't. Let's first check to see for nulls. No nulls. ID number is clearly numeric. Order ID number is numeric. Product code is string. Quantity is numeric. Price is numeric. We don't have any dollar signs there, and that's good. We want to not have any dollar signs yet because we might want to do some stuff with price. Mathematically, we might want to multiply price times quantity to get the total revenue for that order, for example. And we can't do that if we have dollar signs on price. So that's good. These are all 1, 2, 3, 4 should be changed to numeric. Product code can remain string. Let's look at this a little more carefully, though, and just logically. So this ID, I don't know what this ID is, and I think I said in the previous video it's the customer ID. But if you think about this logically, this cannot be the customer ID. That wouldn't make sense. The order ID number should be unique to a given customer. So this is order ID number 30. Order ID number 30. This is the same order. The same order can't be two different customers. What must be the case is this order ID number is for one customer. It's either for customer ID, whatever their customer ID number is, and that customer ordered two different products. We can verify that over here in our orders data set. Order ID 30 was placed by customer 27. They placed the order on this date. We shipped it to them on this date. If we go back to order details, order ID 30, it says ID number 27, but then order ID 30, ID number 28. This isn't right. Order ID 30 is for customer ID 27. That customer placed an order for two different products, 100 of this product and 30 of this product. And so it looks like this ID column, we don't even need this. This doesn't make any sense. It's definitely not the customer ID for the reasons that we just mentioned. So we can, when we attach our select tool to our order details, we can get rid of that column. We don't need that column. Let's not keep ID because it's not the customer ID. It doesn't make sense. And then we'll change order ID number in this data set to double. Product code remains a string. Quantity is double. Price is double. For orders, order ID number should be a numeric variable double. Customer ID should be double. Order date should be date. Ship date should be a date variable type. And I'm looking and there aren't any null values in these columns, so we don't have to worry about that. So we're going to change with not a sample tool. What am I doing here? A select tool. Bring in a select tool. Change the order ID number to double. Customer ID number to double. And we can't change order date to date, time, or date. And we can't change the ship date to a date or a date time variable type yet because it's in the wrong format. For example, if I tried to do that, if we look, remember here at our date here, this is the wrong format. The default format for Alteryx date time or a date variable type is year, then month, then day. So it's not in that format, so we can't, it's going to report an error if we try to do that. So let's leave that as the variable with string. And we'll have to change that using a date time tool that we've taught you in previous videos. And then for products, if we go over here, products, this is a string, numeric, quantity per unit, obviously a string. Notice there's some null values there. And then category, string. So the only null values in all four data sets occur in the product data set on this variable here, standard quantity. Now the question is, do we want to delete these rows in this data set because there's a null value right here in this column? I don't think we want to delete because this information isn't so important. All that matters is the number of units. If we sold either of these two products in a particular order, all that matters is the quantity that we sold. If we sold 100, we don't need to know if it's 100 boxes with 8 granola bars each, or whether it's if this quantity per unit is 1 box times 8 granola bars per box. And in our orders data set, it says we sold 100 quantity of this. That means we sold 100 boxes. But if it says here the standard quantity is 2 boxes with 8 granola bars each, and then in our orders data set it says we sold 100 quantity, that means we actually sold 200 boxes. But how many actual boxes of granola bars we sold isn't really relevant. It's just as long as we can get our cost information and our sales price information right, and it will be right, we don't necessarily need these. Because if we delete these 2 rows in this data set, then if these products appear in any of our orders, we're not going to have the right information when we merge. We're not going to be able to merge. We're going to lose these products. And it's just going to leave us with less data. Now, if the null values occurred on these variables, on price, then we would want to delete these 2 rows, because later on when we try to figure out our most profitable customers, we're going to have to use price. And if a given customer bought these products from us, we won't know what profit we got from that customer, because we won't know what revenue we got from that customer, because these will be null, and we might as well just delete them. So it depends on what variable the null value occurs on. If it occurs on a variable that really isn't influential in our analysis, we don't need to delete. So we won't deal with the null values there. So we do need to attach a select tool here. Product code should be a numeric data type. Product name, no. Product code should remain a string data type. Sorry. Go back and look. In this data set, the only variables that should be numeric are standard cost and list price. So we will change standard cost and list price to double. All right, we can run our workflow. All right, order details. We need to do something over here in order details. Notice we no longer have that other column ID because it didn't mean anything. But there is something we need to do in order details, and I spoke about it here. It was the example I gave you here. Check for values that don't make sense. So in the order details data set, we have 2 orders, or we have an order down here placed by a customer. Order ID number 81. The customer bought this product and this product. It bought a quantity of 0. Well, that doesn't make sense. So we do want to get rid of those two rows. That order 81, we need to get rid of it because a quantity of 0 doesn't make sense. So what we'll do is we'll filter those out with a filter tool. And a filter, we will write custom filter. Basically, quantity equals 0. Actually, quantity not equal. Well, we can say quantity equals 0 is our filter. So when we filter, then we run the workflow. The true portion of this will be that order ID where the quantity equals 0. It was just that one order ID, 81. And the false portion will be all the rows where quantity is not equal to 0, which is all the other rows. That's good. Customers is looking good. Nothing wrong with that. We got the right data types for the variables. Products are looking fine. We got the right data type for the variables. These are both numeric now, and these other ones are string. Again, we don't really care about the null values on this variable because we're not going to use that variable in our analysis. All right. So what we do need to do in our orders data set, we need to change the variable type of these two to date time. So let's do that with our date time tool that we taught you in previous video. Attach a date time tool. If we look at our order date variable and our ship date variable, it's in the format of mm/dd/YYY. So month, day, year. So we go to our date time. We want to convert a string data type to a date time format. Which string field do you want to convert? We'll convert order date. The new variable, we'll just call it date of order. What format was the old variable in? It was in month, month, day, day, year, 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 this format. So we'll hit apply. Then we'll connect another date time tool. Which string do we want to convert? Ship date. We'll rename it date of shipment. It was in a format of month, month, day, day, year, year, year. Now we're going to hit apply and hit run. If we look at our output here, now we should have two new variables, one called date of order, one called date of shipment, and they are in the correct variable format. This is a date time format. This is a date time format. This was a string format. This was a string format. Notice it's year, month, day, separated by dashes. That's the default date time format in Alteryx. When I say date time format, I essentially just mean date format because there's no time here. If we wanted to distinguish what time on this date, there would be an extra a colon and then hours, minutes, seconds. But very rarely do you have to do that there's very rarely a variable that goes to that level of detail in terms of the time of day. So we've done what we need to do up to this point to these four data sets. There is one other thing that we should do here. Just to clean things up, let's attach a select tool over here. We no longer need order date or ship date in there because they're the wrong format, but our new variables, date of order and date of shipment, which are in the right format, the date format, we can move them up here where they should be. So if we hit run and we look, now we have order ID, customer ID, date of order, date of shipment in the right variable type. And then if we look here, it says you will need to create several new variables in the data sets before merging them to form the final database. Use the questions below to guide you on which variables should be created. So question 2, how long on average do orders take to be fulfilled? In other words, what's the average difference between the order date and the ship date? In our orders data set, it's looking like this as of right now. We're wanting for each order the difference between date of order and date of shipment in days. We want that difference. Then we can answer that question. How long on average for an average order? Here's the orders. Here are the order IDs. Each row represents a different order. For the average order, how long does it take to be fulfilled? Customer orders on this date, we ship it on this date, so how many days go by on average? So we need to create a new variable. We can call it order fulfillment time or something like that. Time to fulfill order fulfillment time. And we can do this with the formula tool. So we'll create a new column. We'll call it order fulfillment time. We'll make it a double data type. And it's the difference between date of order and date of shipment. It's date of shipment minus date of order. So if we go and look at our, so it would be for this order, how long did order ID number 30 take to be fulfilled? They ordered on the 15th of January 2017, and we shipped it on January 2017. We shipped it on January 22nd, 2017. So we have to make some assumption here. 22 minus 15 is 7. But if you think about, let's see, we know all of the 16th, that's 1. All of the 17th, that's 2. All of the 18th, that's 3. All of the 19th, that's 4. All of the 20th, that's 5. All of the 21st, that's 6. We know for 6 days, for the entire day, we were working on the order. And then let's assume that they placed the order at the beginning of January 15th. So on the 15th, we worked on the order. That's 7 days. And that we shipped the order at the end of the 22nd. So we worked on the order on the 22nd as well. So that's 8 days. So we're going to assume that the length of the order, we're going to be conservative here in the sense that instead of saying that the time it took to fulfill this order is just the difference in the dates, which would just be 7 days, that would imply that we're assuming that we shipped the order on the beginning of the 22nd. But what if we didn't? What if we shipped it at the end of the 22nd? Then we need to include the 22nd as part of the order fulfillment time. And so what we should do to be conservative is we should just take the difference in these dates and then add 1 to it. That would give us 8 for this order. 8 days it took us to fulfill. And that reflects the assumption that we began working on the order on the beginning of January 15th. At the beginning, they placed the order in the morning, and that we shipped it in the evening of the 22nd. Hopefully that makes sense. So what formula would reflect that? All right, we need to take the difference in between two dates. There's a function in Alteryx, so you're going to learn a new function here called date-time difference, or date-time diff. And here's the syntax. It subtracts the second date from the first date and returns an integer difference in the specified unit. And we want it to be in days. So we need to subtract date of order from date of shipment. So we put date of shipment first, date of order second. Otherwise, we'll get a negative number if we put date of order first. And then comma, and then our units. We're going to put quotation days, end quote. And that'll essentially do January 22nd minus January 15th is 7, but then we want to add 1 to that for the reasons we talked about earlier. And it gives you a data preview of what that first order fulfillment time would be. It'd be January 22nd minus January 15th of 2017, which is 7 days, plus 1, 8. We hit run. So now we should have this new variable, which we called order fulfillment time. And then we can just look at a few of these. Let's just look down here at a random one. This order, they placed it on March 6th. We shipped it on March 9th. So we should have an order fulfillment time of 9 minus 6 plus 1, or 4 days. We could check here on this one is good because it looks at, whoops, sorry. Anyway, I don't know how to get rid of what I just, there. This one is good because it shows we can check when we go from one month to another. So here, March 24th is when they placed the order. Our customer placed the order, and we shipped it to them on April 7th. So we have an order fulfillment time here of 15 days. Does that make sense? The 24th, that's 1. The 25th, that's 2. 26th is 3. 27th is 4. 28th, 5. 29th, 6th, 30th, 7th. March has 31 days in it, so 31, that's 8 days. And then April 1st, 9, April 2nd, 10, 3rd, 11, 4th, 12, 5th, 13, April 6th, 14, April 7th, 15. 15 days. So this, in Alteryx, suppose this was going from February to March. Alteryx knows if the given year is a leap year, it knows how many days February has in it. You know, February changes in its day number, depending on if it's a leap year or not. Alteryx knows which months have 30 days, which months have 31 days. So this date time, this function right here in Alteryx is powerful. The programming behind the function, you know, the programmers who program this function, it already can calculate. In other words, it calculates the right difference in days, no matter what the month is, whether leap years or anything like that. It knows. All right. This concludes the video. We are ready now to merge our 4 data sets together to form the final database that we can then query to answer these 10 questions. I've cleaned the data and gotten it to a point where we can join the data together, the data sets together. So in the next video, we will start with that.